puppy back on.
All right, so everybody's looking at problem number 5.
Fuck you, chicken.
And we have to find
Caleb, I heard that you took a hell of a tumble this morning.
the measure of the angle.
I heard you took a tumble this morning.
Oh, no. We need to find the measure of the angle. Okay, so here we go. Here's how this works.
Because I almost know, but I feel your pains. I almost fell, so that's what
I almost fell with the bottom strip on there.
How is he supposed to protect
Hey,
you?
I do so much talking, I'm not sure anybody's got his or her brain engaged here. You have to figure out what angle is going to have a cosine of 1/2. All right? Now, this is a little bit tricky. I want you to think about,
Should we draw that? This
I would definitely draw that.
So you're gonna,
I want you to think about, we'll do a quadrant at a time. Let's think about this quadrant. Would it be possible to have an angle? Remember, we're always talking about the angle at the origin, so that's always the angle we're talking about. Could this be a 1 and this be a 2? Because cosine is adjacent over hypotenuse. So if I could be in quadrant 1, would that be acceptable?
Yes.
Yes. Now let's look at quadrant 2. So this is a yes, so we'll put a check mark here. Could I be in quadrant 2?
Wait, just to clarify, so the angle that we always use to base the adjacent
Is the one at the origin, always at the origin. So now would it be okay, here's the angle at the origin, to have a 1 here and a 2 here? Would that be okay?
Yes, ma'am.
Actually, it wouldn't, because tell me about this value right here, kids. That's negative. That would have to be a negative value
Trick question.
if you were in quadrant 2. So that won't work, because it's got to be positive. All right, what about here?
No.
It still won't work, because that's still negative, right? How about here?
Yes.
That will work, because that could be 1 and this could be 2. So we have 2 possibilities. If the cosine is going to be a positive number, that could happen in 2 places. It could happen up here in quadrant 1, and it could happen down here in quadrant 4. It can't happen in 2 and 3, because in 2 and 3, the adjacent side is negative. When you go left, rupees, that's negative, right? So we're going to find answers over here. So I'm going to redraw it now with only the ones I want.
So you only look at the x-axis when you're determining?
If you're doing cosine, because cosine is adjacent, and that would be the x side, right? What are you doing?
Just rearranging our photo.
Every day.
Yes.
Okay.
You have a reset.
All right, so here we go.
I think it gives a little.
You have determined that this side can be 1 and this side can be 2. Tell me about that side.
That's,
It's root 3. I don't know who said that, but you're right on target. It's
Thanks,
root
Daddy.
3. And if that's root 3, tell me about the angle that it's across from.
that's, 30 degrees.
60.
60. You guys, you got to know that. Across from the 60 is
Root 3.
root 3. This is the angle that you care about, boys and girls. this is the one you care about, right here. So the answer to the question, one of the answers, is 60 degrees. Now, the nice thing about these two different triangles is they're equal, they're congruent to each other. So this is also a 60. What are you doing, Julia? Yeah. Okay, well, don't. Okay, right now, this is hard stuff. We gotta get this sorted out. So this angle right here is also 60. Now, I don't think we've done this before. You need to tell me, okay, here's the angle that I've drawn, okay? You need to tell me how big that angle is. That is a giant angle. It's all the way around in quadrant 4. How big would that angle be? It isn't 60. 60's up here. How big is that huge angle? 300. And why is it 300? You're exactly right, but what's the logic?
It's true. It's the realest of all angles.
All the way around is how many? 360. Did I go all the way around?
No.
No, I stopped with 60 degrees to go. So all the way around is 360. If I stopped with 60 to go, then I only went 300?
Why did you start like with that 60 like that hypotenuse line? Why did you start
I always start here. We talked about that yesterday.
Quick question.
So I go till I hit the angle. So the first one was just 60 degrees. I just went 60 degrees. This one I had to go all the way around till I hit the angle. Yep, there's two separate problems there. Two separate, well, one problem, two separate answers.
Wait, quick question. So what was the answer to A?
This is A.
Oh, this is still A.
Yeah, these are the answers.
Okay.
There's two of them.
And, okay. I don't know.
Okay?
So we got,
Now we're gonna do B. Now, this one is tricky. I keep telling you guys, there is so much to remember. Abby, are you chewing gum again today? There's so much to remember here. You really have to pay attention. This says, I'm looking now, I'm going to do a situation just like this. I'm going to find the angles that have a sine of root 2 over 2. Now, here's the thing. Root 2 over 2, you have to recognize is the rationalized version of 1 over root 2. Do you recognize, now that I've told you, maybe you didn't get that on your own, but now that I've told you, do you recognize these two things are the same thing?
45 degrees.
Oh, and somebody said the angle's gonna be 45 degrees. You're exactly right.
no, stop him.
This is gonna be a 45-degree angle. We'll look at it here in
How
a
did,
minute.
how did you know that?
Because the root 2.
Because it's an equilibrium triangle, because you have a 1 and a 1.
So when I draw a picture of this, I have to figure out which quadrants I'm going to have answers in. So I'm going to start in quadrant 1 again. Is it possible to have a triangle where the opposite side is 1 and the hypotenuse is root 2?
Yes.
Yes, and as Topham said, that's a 45-degree angle.
So when you're drawing these pictures, does it matter when you put that hypotenuse line, like, as long as you write that it's a 45 degrees?
Yeah, as long as you have it in the right quadrant, you gotta have it in the right quadrant, but yeah. Somewhere in the first quadrant. Now, let's see. Would it be possible in the second quadrant to have a 1 here and a root 2 here? Now, before you start wondering, this is why are you putting the 1 there and the root 2 there? This is a sign problem. Sine is opposite over hypotenuse. The angle at the origin is the one I look at. So this is the opposite, this is the hypotenuse. Get it? Is that possible?
Yeah.
Yep. Let's look down here. Is it possible for this to be 1 and this to be root 2? No, because down there, the 1 would have to be negative, and it isn't. So this isn't going to work. What about over here? Can you put a 1 here and a root 2 here?
That's
That won't work either, because wouldn't that have to be negative?
yeah.
And it's not. So this is where your two answers are this time. That's different than where they were here, because here we were looking at adjacent over hypotenuse. Here I'm looking at opposite over hypotenuse. So I'm looking at different things. This angle's also 45. They always match. The triangles are always congruent, so you don't have to do anything double. It's equal.
But why is that one okay? Because isn't that on the negative side?
I'm looking at the opposite. And the opposite is on the positive side.
Got you, got you. Forgot about that.
Now, this is your first answer. How big is that angle? Well, it's right there. That angle is 45. Here comes a hard one.
135.
Now, somebody got it. I want this angle right here, that big purple angle. Somebody back there said 135, and whoever said it is right on
That was
target.
Topham. Topham's on fire today.
But let's explain it to everybody else. Look, kids, try to digest this. If I went from here all the way to here, how far would that be? 180. I didn't go that far. I stopped here. How much less did I not go? 45? So how did I get 135? 180 minus 45.
Okay, I got you now. I got you. So figure this out.
All right, let's try another one. These are kind of hard. There's no question about it.
Do you know what I found out, Miss Ford? I'm about to take calculus in college, and you know what I told them? I'm gonna be prepared since I got Miss Ford this year.
Yeah. All right, here we go. Hopefully, here we go. I'm gonna label some triangles. See which ones work. Here's my butterfly bow tie.
Butterfly.
I'm going to see which of those triangles work. This says the cosecant is 2 over 1. All right, now wait. Cosecant. I gotta
Opposite
label
over
something.
hypotenuse.
Opposite sign.
It's the reciprocal of the sine. So the sine is opposite over hypotenuse. So cosecant will be hypotenuse over opposite.
Wait, hold on. Let's run that back.
It's
So the original of the code, SOHCAHTOA. Wait, hold on.
Sine is opposite over hypotenuse.
This is
Okay.
cosecant.
The cosecant is the reciprocal of the sine, so it will be hypotenuse over
Okay.
opposite.
Okay, got you. Got you.
Now, forget about any other additional numbers here. Is that possible? Can this be a positive 1?
Yes.
Okay, good. Let's look over here. Can you have this triangle? Yes? Could you have this triangle?
No.
No, because if you were down here, that would be negative, and it's not. So that triangle doesn't work. How about here? Same reason. If you were down here, wouldn't that have to be negative? Jack, your hand up. So, now I have these two answers, and I have to figure out how big these angles are right here, this angle right here.
30.
Topham says that's a 30-degree angle. How does he know? Because what's across from the 1? 30. You memorized that. This one's also 30, because they always match. So one of the answers is right here, and that would be 30 degrees. And one of the answers is over here. And Olivia says 150, and she is exactly right. And how did she get 150? 180 minus 30. Beautiful. Beautiful. These are hard.
Okay, so that worked out because you knew that was a 30-degree angle because that fit the criteria.
Yep.
30, 60.
Yep. Yep. All these are going to have to be 30, 60, 90, or 45, 45, 90.
Okay.
Or we can't do it without a calculator. Okay, let's do one more of these. Tangent equals 1. Now I'm going to go ahead and make that 1 over 1. It says tangent equals 1, but I like to have a fraction. Because I remember that tangent is what?
Opposite over adjacent.
Opposite over adjacent. So I'm going to draw a triangle in quadrant 1. And I'm going to ask myself, can opposite over adjacent be 1 over 1? Would that be acceptable in quadrant 1? Yep. How about in quadrant 2? Would it be acceptable to have that?
No.
No, because in quadrant 2, wouldn't this one have to be negative?
Yeah.
Okay, and it's not, so that doesn't work, so we get rid of that one. Okay, now here I am in quadrant 3.
No.
Now this is where it gets really tricky.
Oh,
No.
it's negative over.
That's actually okay, because this would be negative and that would be negative, but what happens when you put this one over that one?
It becomes a positive.
That's a
It
trick
becomes
question,
positive.
Miss
That
Ford.
is tricky. I told you this stuff's hard. You gotta keep your beady little eyes open. There's stuff going on.
You
So
always
that
keep me
one's
on my
okay.
toes.
What about over here?
Yeah.
It won't work, because that one will be positive, but this one would have to be negative, right? That's not what I need, so that one won't work. So this time, my two answers are here and here. Now, you should be able to tell the size of that angle when you see a 1 and a 1. 45. And this one's 45. How big is that angle right there? That's an easy one. 45. So one of your answers is 45. Now, here's the other angle. And I gotta get all the way from here to here. Any ideas how big that one is? 225. Very good. Now, those of you that aren't getting it, how did we get 225? We started here. How many degrees is it to here? 180. And then we went 45 more. So 180 plus 45 is 225. We need a break from that.
Oh,
That's
thank
hard
you.
stuff.
Woo!
So let's look at number 6.
She is human, guys. I thought sometimes you're just like a little math calculator. I'm like, oh, when's she gonna
Let's
stop?
look at number 6.
Just don't.
Get your calculators out. We need our calculators for part 6. I'll say that one more time for the people who are talking.
Get your calculator out. We gotta do some math, y'all. I got you. Dang, when can I just class?
All right.
Whenever.
We are going to have to use a calculator on this because that's a 28-degree angle. And the only angles you can do without a calculator, the only angles I can do without a calculator are 30, 60, 45s, the special ones. So 28 is not special. So my job is to figure out what x is. Now, I want you to pay attention. This is easy. This kind of problem is easy. Those were very hard. But these are easy. Look at this angle. With regard to that angle, which side is this? Opposite. Which side is this? Hypotenuse. Notice there's nothing down here, so I'm not even going to look at this. This isn't part of the problem. The only things that are part of the problem are the opposite and the hypotenuse. What function, sine, cosine, tangent, secant, cosecant, cotangent, uses opposite over hypotenuse? Sine. So I will say sine 28 equals 10 over x. Does that make sense to everybody? Why did I pick sine? Of all my choices, why did I pick sine? Because it's opposite and hypotenuse. With regard to the 28, this is opposite, that's hypotenuse. Okay? Now, I'm supposed to be solving for x.
I got you. Multiply by 10.
No. Now, you may cross multiply if you want, but you'll have to put this over 1. So when you cross multiply, it will say 10 equals x sine 28. So x will equal 10 divided by sine 28, because you're going to divide both sides by sine 28. So then we take out our calculators. What mode should you be in? Degrees.
Do you have to put the degree mark?
No. If you're in degrees and you're not putting in minutes and all that stuff, then no. You can just type it in. So it'll be 10 divided by sine 28. And I got 21.3.
Diane, ma'am?
Okay, Miss Ford, I know what's happening now. I know your game. I know this.
All right, let's look at the next one. Now you're going to do exactly the same thing, but you got to figure out which function you're going to use. Sine, cosine, tangent, secant, cosecant, cotangent. So I would never recommend using secant, cosecant, or cotangent because you don't have that on your calculator. So I'd stick with sine, cosine, and tangent.
But you could do
Which one are you going to do? Cosine. How did you know you were going to use cosine? This is adjacent and this is hypotenuse. Right?
it.
So we'll say cosine of 13 equals what? What does the cosine of 13 equal? 4 over x. You people are amazing. Good job. Cosine is adjacent over hypotenuse. So now you can cross multiply if you want.
Is there like another method?
So it'll be x cosine 13 equals 4. So x will equal 4 divided by cosine 13.
4.1. Throw it up in the air.
Yep. 4.1.
Told you I know the game.
Taylor, why are you always talking?
But they quick to blame Jabron, aren't they? They used to be quick to blame Jabron, weren't they? Jabron's
Did
the
you
one
say she's
that...
trying to counsel you?
Yeah, she's talking to me. I'm going
Really? Because I used to try to counsel them all last semester. But never said that.
And I'm really trying to hold back tears from what you're running this board.
Let's take a look at this one.
That was a real thought.
We need to figure out which function we're going to use. So we got to take a look at our 52. Never use the 90. Always use the other angle. So we're looking at the 52.
Both of us.
Which side is this? Opposite. Which side is this? Adjacent. So which function is that? TOA, tangent. So we'll say the tangent of 52 equals opposite over adjacent.
What did you just say?
Can I just multiply both sides by 5 to get x by itself?
Yeah.
So x will be 5 times the tangent of 52.
So do you always put the multiple on the outside?
Yes.
I think we're gonna do this.
I got about 6.4. Yep. Would you try D by yourself with your neighbor?
What I'm doing with Tom.
Oh, yeah.
So with Jason was...
Okay, everybody's working on D.
So, cross multiply.
Well, I had to get x by itself, so I times both sides by 5.
Oh, no. How many decimals? This is,
How many decimal points
this is,
Well, there's no direction, so we've been doing just one decimal
Yeah.
place, but you can do whatever the directions we say, it doesn't really
right?
All right, when you're doing these problems, kids, the very first thing you need to do is figure out which function you're going to use. So, Tim Kelly, what function did you guys decide you were going to use on this problem? And why did you pick cosine? Exactly. Here's your angle, adjacent, hypotenuse. So Tim, what was your equation? Perfect. Cosine 17 equal, Taylor,
Were you counseling?
cosine 17 equals x over 10. Now I need to know what x is, so I'm going to multiply both sides by 10. So 10 cosine 17. Tim, what did you get as an answer?
9.56.
Yep, 9.56 if we rounded 2
Good job,
decimal
Tim.
places. 9.56.
Hold it down.
Any question or issue with that? All right, would you get out last night's homework then? And I swear, if somebody says one homework, I'm gonna kill you. Last night we did 19 Anybody have a question about 19 through 40 last night? On page 366. Jack. 24. 24 says find the cosecant of pi over 3. Okay. Everybody's paying attention. This is a very important problem, great problem to look at. Does anybody remember from yesterday how we started this kind of problem? Right, we changed, very good, Bryce, we changed the angle measure into degrees. So we all know that pi is 180. Divided by 3 would be 60. So this is the same as the cosine of 60 degrees. So I will set up my picture just like I did earlier, and I'll go 60 degrees. There it is, there's 60 degrees. Then I'll drop down my perpendicular to make my butterfly bow tie piece, right? And what kind of a triangle do I have here?
Well, you got you one of them classical 30, 60, 90
90.
balls.
Across from the 30 is 1, across from the 60 is root 3, and the hypotenuse is 2. How do I know that? I memorized it. You gotta memorize it. Now, I want the cosecant. What is cosecant? Reciprocal of sine. Sine is opposite over hypotenuse, so I need hypotenuse over opposite. So that would be 2 over root 3.
That sounds about right.
Which I have to rationalize because I'm not allowed to have radicals in the bottom. So your answer, Jack Rocap, is 2 root 3 over 3. Anybody else? Great question. Anybody else from last night's homework? Okay, then I need you to understand what tonight's homework is. Tonight's assignment is in 2 pieces. Part of it is in your book, and part of it is in the packet that I gave you, not the note sheet
The
packet, but the
4.2,
other
4.3.
Yep.
I got you. Which problem?
So get the smaller packet out that I gave you the other day. Remember the other day you picked up 2 packets. One was your note sheets, the other one was some worksheets.
My mom said she wanted to tell me comic book.
Tonight,
Yeah, I don't mind.
Sunday night, or Monday morning, or whenever you do your homework, you will do on this very front worksheet, the special angle worksheet, you will do problems 1 through 4. That's 1, 2, 3, and 4. Then you also have some book work to do. Okay? Everybody clear on what the assignment is? 1, 2, 3, 4 on this worksheet, and then the book problems that I've assigned. Okay, over the next few days, we'll finish this worksheet, but we're going to do it a piece at a time. All right, everybody clear on that? Okay, you've got 3 minutes.
Hey, weren't you in the last game? I saw you there.
Yeah, I went.
What was the last game?
Northwest. I passed. It's a decent film.
I was at the